Hi everyone. I'm Professor Kim. I'm here to talk to you about our civil engineering program. Unfortunately, with the coronavirus, we had to cancel March break open house, but I'm hoping that my presentation here will give you at least a good idea of what our program is like, and really give you a good breakdown of what life is like at Waterloo. So I'll start off with an overview of our academic program, and then I'll introduce some of our department resources we have to help you succeed here at Waterloo. And then I'll introduce our approach to experiential learning, talk about our co-op program. And there's a few slides here on student experience, but unfortunately, with our the university being closed, our student representative couldn't be here today with me. But it'll give you a good sense of what being a student here is like. Just to introduce myself, when it comes to student life here, I feel like I have a pretty good idea. I'm a Waterloo alumnus. I graduated from the civil engineering program in 2011. And then after completing my PhD, I joined the faculty here as an assistant professor in 2018. My main research is on the performance of structures, buildings, and bridges under extreme hazards, things like earthquakes, tsunamis, hurricanes, etc., and retrofitting and strengthening these structures so they have the capacity to withstand such events. In terms of teaching, I teach linear algebra to all first-year students. So if you decide to join us here in the fall, I'll definitely be seeing you. I also teach structural dynamics to fourth-year students and earthquake engineering to at the graduate level. So these are just some pictures from my time here at Waterloo. Top left is me in first year. Top right, that's me on one of my co-op terms, me at convocation, and the bottom left picture is just me today. So let's talk about our program here. So the Department of Civil Engineering, Civil and Environmental Engineering actually consists of 4 different programs. So we have our civil engineering program, geological engineering, environmental engineering, and architectural engineering. As you can kind of see from this diagram, each program has its own unique kind of areas of specialization, but you can also see that there's considerable overlap between them. So choosing to study civil engineering, it doesn't really limit your options. Students still have the freedom to kind of pursue different areas of interest if they would want to. Kind of at the core of our department, the unifying theme that ties all of our programs together is our commitment to sustainability. So our goal here is to develop strong, responsible engineers who have the tools and skills necessary to solve problems and make the world a better place for us and our future generations. So I'm here to just focus on the civil engineering program, and I'd like to kind of start off by saying that civil engineering is a broad field. It really is, and civil engineering is all around us. So it's in civil engineers design the buildings we occupy, the roads and bridges we drive on. They take care of the water we drink, the waste we produce, and even the materials we consume. And so our program introduces our students to all of these different areas and helps them develop strong engineering fundamentals, as well as teaching them the state-of-the-art technology. So as you move through the program, you'll be able to kind of tailor your degree a little bit to a particular specialization by focusing on courses in that area. So you can choose to pursue a geotechnical option, a structural engineering option, a transportation option, or water resources specialization. But this isn't mandatory. And if you instead, you can choose to take a variety of different courses. So you have the tools to tackle a wide range of problems in practice. So in addition to specializations within the department and within the program, we also have options to further enrich and broaden your degree. So options are kind of like minors. And so to complete an option, you have to take additional classes outside of the civil engineering program, but you can pursue options in areas like artificial intelligence or even software engineering. So these are extra tools that you can equip yourself with to really tackle these very complex and some of the emerging problems we have in the world, like things in AI or life sciences, etc. So these, if you do complete an option, this is something that would be reflected on your diploma when you graduate. So this is an overview of our engineering curriculum. As you can see, there's a total of 8 academic terms, with 6 co-op terms kind of slotted in between. I'll talk a little bit more about the co-op terms later. So with our co-op program, it takes a minimum of 4 years and 8 months to complete the program. And an average academic term has about 5 courses. There are terms with more, but the typical term, as you can see, has 5 courses. In first and second year, students are concentrating on fundamental courses like mathematics, physics, materials, computational methods, things that really set the stage for higher level analysis and design courses, which come in third year. And so in third year, you're introduced to the introductory design classes. And this is when you start working towards your specialization if you choose to do so. So specializations, this is how you would do that, is through technical electives, TEs. And in third year, you also have what are called complementary studies electives to get you to explore courses that are outside of the engineering curriculum as well. And then by the time you're in fourth year, you're taking higher level technical electives and focusing on your capstone design project, which is a chance for you to really demonstrate and showcase everything you've learned up to that point through a project that involves a real world engineering problem. So in terms of the workload, I like to tell students that engineering education really is a full-time job. And to demonstrate that, I'll use kind of a typical work term with 5 courses. So if you have 5 courses, each course has 3 hours of lectures per week. So 5 courses, that's 15 hours of lectures per week. This is basically the professor teaching you the material, introducing new concepts. And each course has, in addition to lectures, each course has 1 hour tutorial every week. A tutorial is kind of like a review session where we'll go over the concepts that were introduced in the lecture, maybe do some more example problems, help you really digest that material. In addition, depending on what courses you have in the term, you may also have labs, which typically take 2 to 4 hours per week. So in total, in terms of class hours, you can expect about 20 to 24 hours of in-class time. This is time you spend interacting with the teaching team. 20 to 24 hours per week. In addition to the in-class hours, a typical student will spend about another 2 to 3 hours per day studying or completing assignments. So that's about 10 to 15 hours per week. This is what an average student would put in. So altogether, you can an average student will require about 30 to 40 hours of study time and class time per week. And upon graduation, our students find careers in a wide range of different areas. And so this is just an example of some of the areas our graduates work in. And this includes planning, management, structural design, and even architectural conservation. Because our academic and co-op program are so well developed and respected by our employers, our graduates are always in high demand, and our students generally have no problems quickly finding jobs upon graduation. And of course, at the end of your undergraduate degree, if you want to gain more depth, or if you want to further develop your specialization, graduate studies is always an option. So our program, as you can see, is quite rigorous. If it wasn't, if we would all just be average engineers, we don't produce average engineers at Waterloo. But given in all its rigor, we have lots of resources to really help you succeed. At the faculty and department level, we have many award-winning faculty members, instructors, lecturers, and researchers to help you learn the material and get real-world experience. They're distinguished teachers with excellent track records in both teaching and research. And when you come here and you start in first year, we'll have a dedicated teaching team for first year students. They're professors and support staff who will help you really transition into the university learning environment. And they'll help you develop the proper study skills and time management skills that you're going to need to really succeed here. And really, and to help you really enjoy your time here at UW as well. In addition to faculty support, we have student societies like CGIS, Civil, Environmental, Architectural, and Geological Engineering Society, and also the Waterloo Engineering Society. And these are student-run societies that help students in a variety of different ways, finding jobs, promoting student wellness, promoting equality, diversity, inclusion among students, things like that. And these societies really help bridge any gaps between students and faculty members. And they're really here to help you get the best possible student experience. And so down the road, if you're interested, these societies are excellent opportunities for you to take on more of a leadership role and help other students as well. So in addition to our academic requirements, our academic program, experiential learning is such a big part of our curriculum and who we are. And we strongly believe that to develop engineers who excel at problem solving, you have to combine theory and practice. So this is kind of our approach to engineering education. And so we have lots of hands-on activities and labs. We have so to help students really see and feel and really apply theory that they learn in classrooms to real-world problems. And in addition to in-class activities, we also have lots of design teams, student design teams. that students can join to really compete and showcase their engineering skills. And teams like the Concrete Toboggan and the Concrete Canoe teams, these student teams compete in competitions at both the national and international stages. So students have not only gain hands-on experience, they have fun doing it. In recent years, we've also incorporated what we call design days into our curriculum as well, to help students gain that hands-on experience and expose them to engineering design at an early stage. So civil engineering students in second year will basically tackle a full-on bridge design problem, starting with the conceptualization, design, cost estimates, fabrication, and ultimately testing the bridge by loading it. And it really helps students see engineering problems, real world engineering problems, test their problem solving skills, and tackle projects as they would in real life. And it helps students not only get a feel for what tackling an engineering problem is like, but it helps them, it challenges them to be creative and resourceful, qualities that engineers really need to tackle problems. Students really have fun with this project every year, and faculty members were always impressed by what students are able to come up with. Of course, what differentiates our program here at UW, and a big part of our experiential learning, is our co-op program. In terms of co-op, there are many possibilities, many different possibilities when it comes to co-op jobs. And most students will typically cycle through a wide range of engineering jobs and different working environments and gain experience in many different areas. And the best part of co-op is that your co-op experience counts towards your professional engineering license, the experience requirement for obtaining your professional engineering license. So these are some examples of jobs that our students find on for their co-op terms. The first couple of co-op terms where you maybe don't have the experience or your academic, you're not that far into your academic program, students will typically find more entry-level positions involving drafting or surveying or estimating. But as you gain more experience through more co-op terms, and as you get further into the program, students move on to more engineering duties like field or lab testing, design, and field inspections, etc. As I briefly mentioned earlier, so every student, there's a total of 6 co-op work terms. For civil engineering students on stream 8, your first co-op term comes after you finish first year. And out of the 6 co-op work terms, students must complete at least 5 of them in order to graduate. And as you can see, in terms of employment rate, with the exception of your very first work term, the employment rate in general is almost 100%. So most of our students have no problems finding a co-op job. In first year, your very first work term, as you can kind of imagine, can be a little bit challenging just because again, you don't have that experience and you're only a year into your academic program. But I'll talk a little bit about helping, how help is available to help you find that very first co-op job in a second. In terms of course, a big part of co-op is that we get paid. And by the time you're in your 5th or 6th co-op work terms, students are typically making about $25, $26 per hour on their co-op terms, in addition to gaining valuable, really engineering experience. So finding that very first co-op job can be quite challenging. So what can you do to maximize your chance of landing that first job? A couple of things. You can start with a part-time job or a summer job, or maybe you can volunteer a little bit and do things that really show that you're committed, you're dedicated, and that you make a good employee. And there are also, as a department, things that we do to help students. First, we try to help students have the basic skills that employees are looking for. So we teach first year students surveying, some AutoCAD, and also we get students into technical writing. And also, we have lots of resources at the department level, and at the student level as well, with resume writing, and taking interviews. So in the end, it really is our students that give us our reputation as one of the best engineering schools in Canada and in the world. So that's basically an overview of the civil engineering program. Again, unfortunately, our student representative couldn't be here to talk about the student experience, but hopefully these last few slides give you a good snapshot of what civil engineering students go through in our program. So thank you very much. I hope to see you all here in the fall.